All right, number 4. I'll tell you right now.
Scared.
The optimization problem on your test is similar to this one.
What test?
Your Unit 5 test that's on Friday.
There's only one?
Good question. So, example number 4. So we got a rectangle right here.
Yeah.
Okay. And I want to maximize the area. But the thing is, all I can do is move along this line. So I can just, so if I put it here, okay, it'll look like this. If I put it here, it'd be like this. Okay. So, the rectangle is bounded by the axes, so this and this. Okay. And this graph of y equals negative a half x plus 3.
There's restrictions, man.
Yeah, we got restrictions, or else we would maximize everything with infinity, right?
Yeah, you're right.
All right, so what length and width should the rectangle have so that its area is a maximum? Okay, so step 1 has always been figure out what you're maximizing. Area is to be maximized. What's the area of a rectangle? Sorry. Length times width, but for us, it's going to be x value times the y value.
Yeah. X and Y. No Zs.
No z's. Yeah, so I already messed up this picture a little bit. Okay. But this is x, this is y. All right. Again, we have 2 variables.
Yeah.
Anybody know a way that I can write the y value in terms of x? You literally have y equals in terms of x. So all we're going to do is plug that in here.
Sorry, I wasn't even looking. I was blind. Wow, Miss Simpson. You're so smart.
Now what?
Oil.
You could take the derivative,
Oil.
but I would rather distribute first, right? So I don't have to do a product rule.
Yep.
Are we okay over there?
Tommy, what the hell?
Yeah, what the hell, Tommy?
Be nice to Tommy.
Why?
As I said. Focus, guys. All right, so now I have an equation for the area, and I want to maximize it. So what do? Take the derivative.
You know how to do that, right?
I know how to do it. Do you?
No. If you know how to do it, then I probably won't be able to do it.
All right, so I took the derivative. What comes next? Set it equal to 0.
Wow, we're practicing. Negative. Can't be negative.
All right, so x is equal to 3. Now I've taken the derivative, set it equal to 0. I've got my critical points. What do? Sign chart. Second derivative. So sign chart to make sure it's actually a maximum, because what if it's a minimum? Then our results will be lies. All right, so what's something less than 3? 2?
7.
Okay. When I plug in 2, do I get a positive or a negative value? A positive. Remember, you're plugging into the derivative.
Negative
Okay. Yeah, right here. Derivative. All right, something bigger than 3.
69.
How about 4?
That was pretty cool.
When I plug in 4 here, do I get a positive or negative value? Negative. So because it goes from positive to negative, it's a max. So we have a max at x equals 3. Okay.
Wow,
Good.
it's all coming together.
So that's the width of my rectangle.
With
What about the height?
frick.
Any ideas?
We found X.
We found x. Is there any way to find y? Plug it into what? Yeah, this right here.
Alright, you know that pretty fast. She'll be calculating. You got a fresh cut.
For you decimal lovers.
Hate this. I checked
Questions?
I